In this first problem, we're going to raise the product, right, so multiplication, AC to the negative 9 power. Now to do this, we're going to use this rule right here. If you have a product, in fact, let's write it like this. If you have a product, make it clear it's a product, and you're going to raise it to the nth power, you can distribute that exponent to each one of those factors, getting x to the n times y to the n. So in our case, that a times c to the negative 9, I'm going to take that negative 9 and distribute it to each of those factors. So I'll get a to the negative 9, c to the negative 9. That looks like an a. Let's make it a 9. In number 2, we're going to raise this expression, r to the negative 2 to the 7th power. Now to do this, we're going to use this rule right here. If you have some power, like x to the n, and we're going to raise that to a power, as long as you're raising a power to a power, you're going to multiply the exponent. So you're going to take x to the n times m. Now for us, we have r to the negative 2 to the 7th. So I'm going to multiply the exponents, getting negative 2 times 7, which is r to the negative 14th. Now, I didn't write it here, but the instructions on the problem say to write our answer with positive exponents only. So I'm going to use this rule right here. All right, here's a rule that says if you have a number with a negative exponent, what you can do is just take 1 over x to the positive exponent. So let's take this r to the negative 14 and write it like this. 1 over r to the positive 14. So what the rule says to do is that if you have a base to a negative number, you can just take it 1 over the base and change the exponent to a positive. So just move things up and down just by changing the sign of the exponent. In number 3, we've got a division. I've got x to the 13th divided by x to the 7th. Now, there's a rule here. The rule I'm going to use is this. If I have a division like x to the n over x to the m, I just write the base and take the top exponent, subtract the bottom exponent. So for us, we will have x to the 13 over x to the 7th is going to be, write the common base, x, take the top exponent minus the bottom exponent. This will give us x to the 6th. Now number 4 here, I've got x to the 5th over x to the 9th. I'm going to use the same rule as I used over here, right, because I have a division. So what I'm going to do here is I'm going to write the common base, then I'll take the top exponent minus the bottom exponent. This will give us x to the negative 4. And now I'll use this rule here. All right, so I've got x to a negative exponent. I'm going to use this rule where I'm just going to write this as the 1 over the base to the positive exponent. All right, so drop the x down and change the sign of the exponent. So I'm going to write this now as 1 over x to the positive 4. What do you think about number 5? Now what we're going to have to do here is we're going to assume that a is not equal to 0, or this thing will be undefined. So what do we get here? Well, look at this. A couple ways to look at it. Whenever you divide any number by itself, you're going to get 1. But if I use the rule of exponents, right, the rule I'm going to use is this one. I have a division, so I take the top exponent minus the bottom exponent. So write that common base. Top exponent minus the bottom exponent, so I get a to the 0. But a to the 0, that's 1 as long as a is not equal to 0. All right? Now, number 6, we are given, we want to simplify this, y to the 0, and we're given that y is not 0. Now, by definition, as long as that base is not 0, we're going to say that y to the 0 is 1. Now, number 7, we're just putting a little bit more together. We've got 5 times y to the 0, and we're given here that y is not equal to 0. So if y is not equal to 0, that means we have 5 times 1, which is 5. Now, in this problem, we've got 3 times this quantity here, 4d raised to the 0 power. Now, we're assuming, the problem tells us, assume that d is not 0. So if d is not 0, then 4d, right, if d is not 0, right, if this d is not 0, 4 times non-zero is non-zero. So that means that 4d is not 0. So the base here is not 0. So this part right here is a 1. So we've got 3 times 1, which is 3. And in number 9, they're telling us that y is not 0. So if y is not 0, okay, then negative 3 times y is not 0. So this thing right here, this is not 0. So this part here must be a 1. So now I've got negative 2 times 1, which is negative 2. And here in number 10, we want to simplify this expression, and the problem tells us that x, y, and z, these are non-zero numbers. Now, as long as I know that they're not 0, then what do you have for this one right here? Z to the 0, as long as the base is not 0, z to the 0 is a 1. So now we're looking at this, 9x squared y to the 4th times 1, which is just 9x squared y to the 4th. And in number 11, we're raising a power to a power. So when you raise a power to a power, you multiply the exponent. So we're going to get x to the 5 times 2, which is x to the 10th. In 12, we've got this product. I got a multiplication here, so that's a product raised to a power. Now, as long as you have a product raised to a power, you can distribute that exponent. So we are going to get 2 to the 3rd, z to the 3rd, and 2 to the 3rd, we can actually do that. It's 2 times 2 times 2, z cubed. So 2 times 2 times 2, that's 8. 8z cubed is what we get. In 13, look in here. We've got a multiplication, right? That's a product. I've got m to the 5th times n. So I'm raising a product to a power. So I'm going to distribute the exponent to each one. Now I'll do this in parts here. I'll get m to the 5th cubed times n cubed. Right? Take that 3 and put it over here and here. Distribute it. Now look at this one right here. I've got a power raised to a power, so I can multiply the exponent. So m to the 5th, m to the 5 times 3, n cubed. 5 times 3 is 15. I'll get m to the 15 n cubed. And of course, if you can just do this, I mean, you can see what's happening here. Just multiply through, right? You can go, I think you can go from this step directly to this step. In 14, what we have is, look at the base. The base is a product. So I'm taking a product and raising it to a power. So I know what to do here. As long as it's a multiplication or division inside here, I can distribute the power. So I'm going to distribute that 2 over here to the negative 3 and then to that x to the 4th. So if I write it all out, it's going to look like this. I'll get negative 3 squared and then x to the 4th squared. Now, negative 3 squared, negative 3 times negative 3 is 9. And the x to the 4th squared, all right, I'll show it. But you know what you're going to do. You're raising a power and multiply those exponents. So here's what we're going to get. We're going to get 9x to the 8th